Good afternoon, everyone. My name is Wilder, and today I'm going to be reading A History of Near-Earth Objects Research. This is an official ebook by NASA. I found it through NASA's website, and it is written by Erik, Conway, Donald Yeomans, and Meg Rosenburg. On January 7th, 2016, the National Aeronautics and Space Administration, NASA, established the Planetary Defense Coordination Office. Built on the foundation of NASA's older Near-Earth Objects Observations program, this new organization is intended to continue funding and coordinating ongoing search and research efforts for near-Earth objects, generally shorthanded as NEOs, identify strategies to reduce the risk of future large impacts by NEOs, called mitigation, and coordinate emergency response actions with other federal agencies and international partners. The new office's initial budget was set at $40 million per year, up from about $4 million in 2010. A number of highly public recent events preceded this action. Most prominently, an object about 20 meters in diameter had impacted Earth's atmosphere and exploded at an altitude of about 23 kilometers near the Russian city of Chelyabinsk on February 15th, 2013, releasing the energy equivalent of about 500 kilotons of TNT. The explosion was high enough above the surface that it did only modest structural damage, but even so, there were over 1,500 injuries, mostly from glass shattered by the violent shockwave initiated in the blast. By chance, the fireball was recorded on dashboard cameras installed by Russian citizens to record accidents and police encounters, resulting in an unprecedented circumstance. Unlike every other known NEO impact, the Chelyabinsk airburst was a visual event that could be widely shared and broadcast worldwide. The Chelyabinsk event was the largest NEO airblast since the Russian Tunguska event of 1908. The energy of that explosion, though poorly recorded due to the location's remoteness in a Siberian forest and the lack of communications technologies, is gauged to have been about an order of magnitude greater than Chelyabinsk's. Estimated to have been about 40 meters in diameter, the Tunguska impactor flattened about 2,200 square kilometers of forest. For comparison, the largest recorded California wildfire as of September 2021, ignited by lightning and known as the August Complex Fire of August 2020, burned nearly 4,200 square kilometers. These extraterrestrial visitations have always happened. Earth experiences annual meteor showers of objects that are nearly always too small to reach the surface. These clouds of near-Earth objects have names. The Perseids occur in August, while the Geminids occur in December. They are the result of Earth's passage through the debris trails of comets or asteroids, with the Perseids, for example, originating with the comet Swift-Tuttle and the Geminids with asteroid 3200 Phaethon. And there were other such showers too. Ancient civilizations knew of them, though they generally interpreted them as signs from their gods, and not as we do, as relics of the solar system formation process. Interestingly, for most of human history, these apparitions were often imbued with malign intent. They were, in other words, seen as portending ill. The idea of cosmic risk. The classical astronomer who probably did the most to categorize the variety of damage foretold by comet appearances was Claudius Ptolemaeus, AD 100 to 175, usually called Ptolemy. Ptolemy is mostly known for his Almagest, the treatise in which he developed the theory of epicycles to describe the motions of the heavenly bodies. In Ptolemy's cosmology, the heavens rotated around a spot slightly off-center from a stationary Earth. Although incorrect, Ptolemy's theory predicted the motion of the known planets and stars quite accurately, well within the measurement capabilities of astronomers for another 16 centuries. Because of this, Ptolemy remained a central authority in astronomy until the Renaissance. Ptolemy's Almagest did not include comets because he, like the influential Greek philosopher Aristotle, 384 to 322 BC, before him did not consider them heavenly bodies. Aristotle had considered them emanations arising from Earth itself, while Ptolemy only mentioned comets once in his astrological work, the Tetrabiblos. In this work, he described in some detail how one could read the omen represented by a comet's apparition. Its position with respect to the sun indicated the timing of the coming disaster, while its tail noted the location. The shape of the comet was supposed to foretell the nature of the disaster. The Tetrabiblos was just as influential as the Almagest, though in a different way. It was embedded in Catholic theology during the many centuries of the European Middle Ages. If classical astronomy can be seen as an effort to understand and predict the motions of heavenly bodies, classical astrology can be interpreted as astronomers' efforts to predict the influence of those bodies on humans and on human events. Ptolemy was not alone in practicing astronomy and astrology simultaneously, though he placed them in different books. Most astronomers prior to the modern era made their livings as astrologers. Society's wealthier members were much more interested in predictions relevant to everyday life than they were in the mere motion of the heavens. This was equally true in ancient China, where court astronomers had been making detailed observations of the heavens and of comets for centuries before the Almagest in order to provide astrological advice to their rulers. Finally, it is important to note that while pre-modern civilizations saw comets as omens of ill fortune, they did not see comets as the cause of that ill fortune. Fickle or vengeful gods and goddesses were the actual agents of destruction. Comets were merely warnings. The Almagest influence gradually broke down among Western astronomers during the 17th century, rooted as it was in the failing notion of geocentrism. It is less clear that the influence of the Tetrabiblos ever did fade completely, although it is no longer part of Christian doctrine. Comet apparitions of 1607 and 1618 once more sparked debate among astronomers over their nature. The 1618 comet was the first to be observed with a telescope, and astronomers began to understand them as physical objects rather than as omens sent by deities. But comets were also not quite fully accepted as permanent features of the cosmos. Kepler, who in this era demonstrated that planetary orbits were calculable as ellipses, believed comets were ephemeral and moved in straight lines. Other period astronomers believed them eternal, moving in orbits, though not necessarily centered on the sun. Edmund Halley's 1705 treatise on comets began to solidify elite opinion around the idea that at least some comets were repeat visitors. Using a technique developed by Isaac Newton, he computed orbits for 24 comets that had appeared between 1337 and 1698, and he contended that a single comet actually accounted for 3 of those visits. It had appeared in 1531, 1607, and 1682. He also predicted its return in late 1758 or early 1759. Though Halley did not live to see his comet's next reappearance, it did return. A German amateur made the first recorded observation on Christmas evening, 1758. Halley's comet, as we now name it, settled the question about cometary longevity and rendered these objects relatively predictable members of the cosmos. If one could track a comet for the few days or weeks of an apparition, one could generate its orbital characteristics and predict its future motion. Halley also had the foresight to wonder what would happen should a comet strike Earth, but he did not strongly pursue the question, perhaps wisely, for the sake of his reputation. The same century in which Halley's comet prediction was made and confirmed also witnessed the development of the doctrine of uniformitarianism within the natural sciences. Uniformitarianism taught in various formulations that the present is the key to the past. It was articulated in 1795 by James Hutton and subsequently popularized and purged of its religious overtones by John Playfair's 1802 revival, Illustrations of the Huttonian Theory of the Earth. Uniformitarianism proposed that the same natural laws and processes operating today have always operated throughout Earth history at the same rate and across the entire planet. No powers are to be employed that are not natural to the globe, no action to be admitted of those except of which we know the principle, and no extraordinary events to be alleged in order to explain a common appearance. Hutton's uniformitarianism was adopted by Charles Lyell, whose Principles of Geology, published between 1830 and 1833, established it as a central tenet of geological thinking in the 19th century. In a prior statement, Hutton illustrated the distasteful connotation attached to the catastrophic side, rejecting appeals to any destructive accident in nature or to the agency of preternatural cause in explaining what actually appears. For both Hutton and Lyell, changes on Earth, like the gradual cycles of erosion or uplift, occurred over an inconceivably vast time span, providing no hope of deducing either a beginning or an end. Intended to remove natural science from theology, for example, the biblical flood would be a catastrophic and thus unacceptable as an explanation under uniformitarian ideals. It also led scientists to reject natural cataclysms as an explanation for Earth's features. Extraterrestrial impacts could not be shapers of Earth. Thus, one interesting effect of uniformitarianism on the earth sciences was the separation of Earth from its cosmos. Only the sun and moon were permitted to have influence on Earth. By the end of the 19th century, not only were comets no longer widely seen as omens of ill events, they were no longer seen as relevant to human or earthly affairs at all. Rocks from space. Comets were but one type of occasional celestial visitor. Meteors, and the mysterious remnants they occasionally left behind, were another. Reports of meteorite falls date back nearly as far as the dawn of written history, with accounts preserved in ancient Egyptian, Chinese, Greek, and Roman literature. Myths and religious writings record still more ancient events, such as a set of traditions related to the Campo del Cielo fall in northern Argentina 4,000 to 5,000 years ago. The Bible passage referring to the Temple of Artemis in Ephesus as the image that fell down from Jupiter. The Phoenician legend of Astarte, bringing a star fallen from the sky to the island of Tyre to be worshipped, and the disputed meteoric origin of the black stone of the Kaaba in Mecca. Tools and items of religious significance made of meteoric iron have also been discovered at many archaeological sites. The oldest known worked iron artifacts are a collection of Egyptian beads dated to 3200 BC, made of hammered and rolled meteoric iron, and the extraterrestrial signature of a knife taken from the tomb of King Tutankhamun in 1925 has recently been confirmed by chemical analysis. Many Native American artifacts have been discovered at burial sites across North America, and several Chinese Bronze Age axe heads containing meteoric iron blades have been documented. Despite these widespread accounts and the demonstrated influence of meteorite falls on cultural myths and traditions, they were not generally accepted as rocks from space until well into the 19th century. The absence of known source bodies, pressure to find explanations in known terrestrial phenomena, and skepticism of eyewitness accounts all played a role in fostering doubts as to the extraterrestrial origin of meteorites. In the 1700s, the conception of the divinely maintained clockwork solar system established by Isaac Newton was no place for stray objects. Even when observations of comets and stellar novae established that the universe does indeed change over time, the existence of cosmic debris remained difficult to accept.